All right, here in lesson 5, we're going to talk about using the inverse from lesson 4 to help us solve matrix equations as well as systems of equations. All right, so first of all, yesterday we learned how to find the inverse of a matrix. I don't want us to forget like why we did that. It's kind of how we're going to start. But it says, are the two matrices, A and B, inverses of each other? And how can we tell? One thing we want to remember is that to determine, we're going to ask if I multiply A by its inverse, do I get the identity matrix? Right? When we multiply an inverse or a matrix by its inverse, do we get the equivalent of 1? So I say we kind of multiply these together. So I'm going to do 3, 4, 1, 2, and I'm going to multiply that by 1, negative 2, negative 1/2, and 1. Now I'm multiplying 2 by 2 by a 2 by 2, so I'm going to get another 2 by 2. I'm going to leave myself a little bit of extra room in there. All right, here we go. My left hand is going side to side, my right hand is going up and down. So 3 times 1 is 3. Move both hands. 4 times negative 1/2 is negative 2. All right, so what do I get in that top right corner? I get a 1. That's a good start, right? Because that identity matrix should have a 1 in the top left corner. All right, moving on. I'm going to go to the second column. 3 times negative 2 is negative 6. Move both hands. 4 times 1 is 2. 4 times 1 is 4. I was already doing the addition. And when I add those together, I get negative 2. Now I'm going to stop there because they can't be inverses, because remember the identity matrix goes 1, 0, 0, 1, and if I have a negative 2 there, it should be a 0. I mean, maybe I should check my work first, but the answer is no, they are not inverses, because when we multiply them together, we can already see we're not going to get the identity matrix. So that's just kind of bringing us back to what we were doing yesterday. All right, so let's go back to where we were yesterday at the beginning of our lesson. If I have a matrix times this matrix, and that gives me a new matrix, how do I find this new matrix? Well, we said if division's off the table, right, there is no such thing as matrix division. Well, the whole point yesterday was, could we use an inverse? So just jogging our memories, if we had something like 2 times x was equal to 5, we said instead of dividing by 2, we can multiply both sides by 1/2, and that'll give us the same result. Now, notice I put the 1/2 on the left here, but instead of squeezing, I put it on the right, and it doesn't matter. With numbers, we said order doesn't matter. The biggest thing is that we multiplied both sides by 1/2, and that left us with a 1x equals 5/2. Now, in the world of matrices, the order of multiplication does matter. So if I'm going to multiply the 1/2 on the left, I need to put the 1/2 on the left over here in the world of matrices. So let's write this down. If I have matrix A times matrix X equals, and I'm going to come over here and write matrix B. I left space for a reason. If I want to get x by itself, I need to multiply both sides by the inverse of matrix A, but the order matters. If I'm going to put it on the left on this side, I need to put it on the left on this side. Now, why did I do that? Because when you have a matrix times its inverse, that will give you the identity matrix. And we've been saying if you multiply a matrix by the identity matrix, it doesn't change. So I wrote out a lot of steps. We're probably not going to write all these steps out. But if you want to get a matrix by itself, we're going to multiply both sides by the inverse of this matrix. And we probably won't write it all out, but that's essentially what we're going to do. All right, so here's what I'm going to do. I'm technically, if I call this matrix A, I want to multiply by the inverse of A on both sides. So I'm going to have matrix X equals the inverse of matrix A times this matrix B. So I kind of did a couple things at once. I am going to find the inverse of this, but again, all of this didn't seem like it was getting us anywhere, so I just did it all on the right side. Okay, so I'm going to take the inverse of this and multiply it on the left of this matrix over here. Well, this is what we learned how to do yesterday. I'm not saying we did this exact matrix, but we're going to do it now. If we want to find the inverse, we need the determinant, and the determinant will be 3 times 1 minus negative 2 times 1, or 3 plus 2, which is 5. So I'm going to have a 1/5. We're going to switch the 1 and the 3, and we're going to change the other signs. So that right there is the inverse, or the beginnings of the inverse, and I want to multiply it by this 8219. All right, now here's the thing. If I go in and multiply everything by 1/5, I'm going to have a lot of messy fractions. The good news is we are allowed to multiply these first. And then we can do the scalar product at the end. And I think we're going to prefer that. So matrix X equals 1/5 times. Now, we're going to multiply a 2 by 2 by another 2 by 2. So we're going to get a 2 by 2. All right, here we go. 1 times 8 is 8. Move both hands. 2 times 1 is 2. 1 times 2 is 2. 2 times 9 is 18. We'll get a negative 8 and a 3 and negative 2 and a 27. We are almost done. So matrix X equals 1/5 times 10, 20, negative 5, 25. And how nice is that, that all of these matrices, or all of these elements, are all divisible by 5. So matrix X, our missing matrix, let's see, 10 divided by 5 is 2, 20 divided by 5 is 4, negative 5 divided by 5 is negative 1, and my last element is 5. That's our missing matrix. And if I wanted to check this, I'd go plug it back in here and multiply this times our new matrix should get us this one. Good. All right. Now, in your homework, you've noticed I've been putting some linear systems in there. Just, sometimes spiral review, but actually in this case, it was purposeful review for what's coming up. So, this is a system of equations. We've got x's and y's. And I said pick a method you can solve by substitution or elimination. Either way, we should get the point of intersection is 2, negative 4, right? We said x equals 2 and y equals negative 4. But then we remember that a system is where two lines intersect, and so we wrote it as an ordered pair. All right, well, I did this for a reason. I'm saying show that this system here can be written in matrices. Okay, well, let's pay attention to that equal sign, but I've got this matrix times this matrix equals this matrix here. Now, what I want you to notice is if I go to the original and I put those coefficients in, maybe I'll just put them in with blue pen. There's a 4 in front of the x, there's a 2 in front of the y. There's a 1 in front of the x, there's a 1 in front of the y. Look at those numbers in there. This is my coefficient matrix, 4, 2, 1, 1, 4, 2, 1, 1. The variables were x and y, and then after the equal sign, if I stack those are it's my constant matrix. Well, let's see that this actually is the same thing. Let's multiply these. Now, if I'm going to multiply a 2 by 2 by a 2 by 1, yes, I can multiply them, and I'm going to get a 2 by 1. Now it looks like I'm writing a 2 by 2, but just because I want that to be wide. All right, here we go. I'm going to go side to side here, up and down here. 4 times x is 4 times x. Move both hands. 2 times y is 2 times y. We're going to add them together. Oh, look at that. 4x plus 2y. All right, second row, first column. 1 times x is 1x. Move both hands. 1 times y is 1y. Add them together. And then that should equal 0, -2. Now this is what we call equal matrices. If matrices are equal, then their corresponding elements should be equal. So this element should be 0, this should be 0, and this element should be -2. And so this is just an interesting way to say, if you have a system of equations in standard form, I'm actually going to write this down. If you have a system of equations in standard form, we can turn it into a matrix equation. Okay, so I set this element equal to that element, and this element, and now we're right back to where we started. Okay, why is this helpful? Because now we have another way to solve the system using what we did up here. How do we solve matrix equations? We're going to use the inverse. So if I want to get this matrix by itself, I'm going to multiply the other side by the inverse. So I'm going to say matrix xy equals the inverse of this matrix times the 2 by 1 matrix 0, -2. Right, so we're not dividing by this, we're multiplying both sides by the inverse. Great. All right, so here we go. I need the inverse of this, which means I need the determinant of that. So I get 4 times 1 minus 2 times 1. So my determinant is 2. So that means I'm going to have 1 over 2. I'm going to switch the 1 and the 4, and I'm going to change the other signs. Great. So again, I could multiply everything in here by 1/2, and maybe you don't mind the fractions, maybe you do. Or maybe you want to multiply these first and then take care of the scalar product. That's what I'm going to choose to do. So I've got the 1/2 times. Now, I've got a 2 by 2 being multiplied by a 2 by 1, which means I'm going to get a 2 by 1. All right, here we go. 1 times 0 is 0. Move both hands. -2 times -2 is +4. I come down here. -1 times 0 is 0. Move both hands. 4 times -2 is -8. Add those together. And so now I can say my unknown matrix is equal to 1/2 of a 4, -8 matrix. Or, how about a 2, -4? And what does this even mean? That means x equals 2 and y equals -4. Oh, which is the exact answer that we got in our homework. It's just another way to solve systems. And you might say, it's the worst way. Okay, potentially, but it might be a nice option when we have 3 by 3s or 4 by 4s and we have a calculator available to us. So procedurally, it's actually a really nice option for solving systems. All right, so let's take a look at the next one. It says, solve the system of equations by first writing the system as a matrix equation and solving by hand. All right, so what we saw in our previous on the front was that you can take this, if it's in standard form, you can have your coefficient matrix, so 2, 3, 10, 16, times your variable matrix xy, and that will equal your constant matrix 1, 2. Now, I'm kind of wishing I would have done myself a favor. I'm kind of wishing I would have divided this whole equation by 2. That would have been a little bit better, but I didn't. If you want to now, feel free. It's going to keep your numbers smaller along the way. All right, so if we want to get xy by itself, we're going to multiply both sides by the inverse of this. So I'm going to go find the determinant of this matrix. 2 times 16 is 32. 3 times 10 is 30. So 32 minus 30 is, 2. Okay, so even though the numbers looked big, it's not that bad. So we've got xy equals 1 over 2. I'm going to switch the 16 and the 2. I'm going to change the signs of the negative 3 and 10. Now, listen, I gave us all this room over here, so feel free to, whenever you need to move over, move over. Again, my preference or my suggestion is to multiply these first if it looks like you don't want to distribute that 1/2. I actually think I might do that here. I don't mind have a decimal there. So I think this time I'm going to keep my numbers smaller by putting that determinant in there. So I'm going to cut everything in half. I've got an 8, a negative 3/2, a negative 5, and a positive 1. So I just kind of case by case will decide when I want to deal with that scalar first or last. All right, but we're ready to multiply now. A 2 by 2 being multiplied by a 2 by 1 will give me another 2 by 1. Here we go. 8 times 1 is 8. Negative 3/2 times 2 is negative 3. Negative 5 times 1 is negative 5. 1 times 2 is 2. And so I've got xy equals 5, negative 3, which means x equals 5 and y equals negative 3. So my solution to the system is the 0.5, negative 3. All right, let's take a look at the last one. Same kind of thing. It says write this system as a matrix equation, but then we're going to use a calculator to solve for x and y. Just takes all the work out of it. Now we do need to be careful because look at here, x's then y's then the constant, but down here not in the same order, and that is a big deal. So let's rewrite this. 2x plus 8y equals 13. Negative 4x plus y equals 11. That's the system we're going to use. So we're going to start by pulling out our coefficients in that order. 2, 8, negative 4, 1. Multiply that by xy, and then that should be equal to our constant matrix. Awesome. So we will use a calculator, but we have to understand what we're going to ask the calculator to do. So if we want to get this matrix by itself, we're going to multiply both sides by the inverse. And now this is where the calculator is going to come in handy. So I am going to go type in this exactly as I see it right here. So I've got a 2 by 2. I'm going to find the inverse of that. Oops. Times, now I have a 2 by 1. I can just grab that one right there. Yikes, look at those answers. Good thing we had a calculator. So I have, x equals, let me switch these sides, how's that? So, there, we have x equals negative 75/34, y equals 37/17. which means my solution or my intersection point looks like that. Okay, good thing we didn't do that one by hand. Let's talk about using an 84 for that real quick before we stop. I mean, we're going to type in the exact same thing. So I'm going to have a 2 by 2. I'm going to fill in my numbers. 2, 8, negative 4, 1. I'm going to raise it to the negative first. Times, and now I need a 2 by 1, which is a 13, 11. And remember, we talked about this on the 84. It will not automatically give you fractions. Some of the newer calculators will, the new 84s will. This one did not, so I'm going to hit my math button, right? I'm immediately hitting my math button and hitting enter. I want to take that answer and turn it into a fraction. And there it is, same answer, right?